Today, we're going to do something really cool. We're going to take a real-world, practical shell script and just tear it apart, piece by piece. My goal here is to show you just how simple and incredibly powerful a few lines of code can be. So, let's get right into it. I want you to think about this for a second. What if your server, instead of just, silently crashing and ruining your day, could actually raise its hand and say, hey, I'm not feeling so great over here? Well, that's exactly what a health monitor script does. It gives your server a voice. It turns it from this passive box of circuits into a proactive partner that warns you before things go completely off the rails. All right, so every good doctor needs a playbook, right? They need to know what temperature counts as a fever or what heart rate is cause for alarm. Our script is no different. We're going to start by looking at its blueprint, the high-level settings that basically define what's normal and what's an emergency.
And here are those rules. Right at the very top of our script, we set these super simple variables. You can just think of them as the fever points for our server. We're telling it, look, if the disk space gets over 80% full, that's a problem. Same thing for the CPU and memory. If they hit 75%, it's time to sound the alarm. We also give it a list of critical services to keep an eye on. It's really that simple.
Okay, so we've got the rules down. Now let's pop open the doctor's bag and see what tools we're working with. The real heart of this script is a set of functions, and it's best to think of each one as its own specialized diagnostic tool. Each one has a very specific job, and it does that one job really, really well.
First up in the kit, we have the disk space analyzer. Its one and only mission is to scan the hard drives and make sure we're not about to run out of room, which, as you probably know, is a super common reason that servers get into trouble in the first place. And this little snippet of code is where the magic happens. After the script figures out the disk usage percentage, it hits this simple if statement. All it's doing is asking one question. Is this usage number bigger than that threshold was set earlier? If the answer is yes, boom, it logs an alert. That's it.
So to put it even more simply, it's just a three-step dance. 1. List all the drives. 2. For each drive, grab that one important number, the usage percentage. And 3. Compare that number to our 80% rule. If it's over the limit, it shouts for help by writing a message to our log file. Simple, effective, and completely automated.
All right, let's move on to our next couple of tools, which basically work as a team. I like to think of them as the heart rate and blood pressure monitors for our server. They keep a close, constant eye on the server's brain, the CPU, and its short-term memory, making sure neither of them are being overworked.
So how does it get these vitals? Well, it's not doing anything super fancy. It's just running a couple of standard Linux commands that you've probably used a million times, top and free, to get the raw data. Then it uses a little bit of text processing magic with tools like grep and awk to find and pull out the exact percentage that it needs.
And the logic here is just beautifully straightforward. Get a number for the CPU, get another number for the memory. Compare each of those numbers to our 75% rule. If either one is too high, it logs an alert. There's no complex algorithm, just a direct, simple check of the server's vitals.
And now, for my personal favorite part, and what I think is the smartest tool in this whole kit, the Service Medic. This is where things get really cool, because this tool doesn't just diagnose a problem, it actually tries to fix it. This is the part of the script that makes it truly proactive, not just a passive reporter.
Here's the brain of the medic. It's another simple if statement that asks, is this service running? If everything is okay, it just makes a note. But if the service is not running, that else block kicks in. And what does it do? First, it screams alert into the log file. Then, and this is the awesome part, it immediately runs the systemctl restart command to try and bring the service back to life, all by itself.
Yeah, looking at it this way, side by side really makes the power of this thing crystal clear. It has two completely different modes. If things are good, it's just a quiet record keeper. But if a service goes down, it instantly transforms into a first responder. It identifies the problem, it takes immediate action to try and fix it, and then it documents exactly what it did. That is a huge step up from just getting an error message.
So we have all these amazing individual tools, right? The disk checker, the CPU watchdog, the service medic. But how do they all work together in a coordinated way? Well, that's the job of the main part of the script. You can think of it as the head doctor, making the rounds and telling each specialist when it's their turn to do their checkup. And the checkup itself is just a clean, step-by-step process. First, it makes a little note in the log file that says, hey, I'm starting a health check. Then it just calls each of our diagnostic tools one after the other. Check the disk, check the CPU, check the memory, check the services. And when it's all done, it logs one last message saying, Checkup complete. Nice and orderly.
Now, running a manual checkup is great and all, but the real magic of scripting, the whole point is automation. So the final piece of this puzzle is to take this script that we've built and turn it into a tireless little robot that works for us 24/7 without us ever having to lift a finger.
And believe it or not, turning on this automation is incredibly easy. It's just 2 little commands. First, we use chmod to make the script executable. You can think of this as giving our doctor its medical license. Second, we add one single line to a system scheduler called cron, and we just tell it, hey cron, run this script for me on the hour, every hour. That's it, we're done. Our server now has its own personal doctor, on call, around the clock, forever.
Let's just pause for a moment and take a step back, because by breaking down this one single project, you've actually unlocked a whole set of fundamental, incredibly valuable, real-world coding skills.
We used variables to set our rules in an easy-to-change way, and we used functions to build these clean, reusable diagnostic tools. That's the bedrock of writing organized code. We used if-else logic to give our script a brain so it could make decisions. And we used loops so we could check every disk and every service without us having to repeat our code over and over again. And finally, we learned how to log everything that happens to a file, creating a permanent record. And we used cron to put the entire process on complete autopilot. These are huge practical skills. So there you have it, 7 powerful real-world skills, all packed into one single, simple script. And this isn't just abstract theory. These are the actual building blocks you need to go out and start solving your own problems.
You've seen the blueprint now. You know how to build a doctor for a server. You've seen how to check system stats, how to make decisions, and how to automate actions. So the real question is, what are you going to build next? What repetitive, annoying task in your life could you solve by creating your own smart, automated helper?